Okay, we are moving on today with our next lesson. We're going to talk about how to solve trigonometric equations. We'll get to that in just a minute, but don't forget about the deadlines happening over the next couple of days. Tomorrow morning by 8:05 is the last time to retake last week's exam. Okay, if you want to go ahead and do that. And Friday morning by 8:05 is the deadline if you want to retake the happy minutes from what week? The 14th. To the 18th. There we go. 14th to the 18th. Okay, so that if it applies to you, please get that taken care of. 2 weeks from Friday on the 15th is when the end of the 6 weeks is already here, and it's going to be pretty quick, especially with next week being another short week. So if you have any questions, please let me know. What's happening tomorrow? Got a quiz over what? The double angle identities, okay. So it's actually going to be really similar to the first questions on your homework. Okay, where you have to create a triangle, just plug into the formula, get the ratio. So if you know those identities, it should be pretty straightforward. If you don't, then it's going to be, kind of difficult. So please make sure you know those 5 identities. Remember I said 5 because cosine 2 theta has 3 different versions. Okay, and you can choose whichever version you like best. Now, as of next week, with Monday, you guys are off. We have a content focus day. It's going to be a short week. I've still got the test scheduled for Thursday. I've created it. It's going to cover double angle identities and solving trig equations. So I'm believing we should have enough time to get through the lesson. As far as everything else, kind of depends on if I think you guys are feeling pretty comfortable with it or not, if I decide to go ahead and move the test. But I'll let you know if that's going to happen. But for right now, let's plan on Thursday of next week. Okay, so got a little over a week before that happens. All right, any questions? Okay, well, let's talk about some trig equations. A trigonometric equation is an equation that contains a trig expression with a variable, such as sine of x. It could be any variable, theta, alpha, beta, any of those that we've used before. Identities, such as this Pythagorean identity, are true for every value of the variable. Solutions are the values that satisfy the equations. So you want the angle measures that are going to make this a true statement. And sometimes there could be quite a few. We will begin by finding solutions for one revolution from 0 to 2 pi. And actually that 2 pi should not be included because it's coterminal with 0, so we don't need to include it. And then expand to find the general solutions of these equations. So for these first couple, I'm going to go ahead and do like I did yesterday. We're going to talk about the general form, every solution that's possible, and then we're going to be very specific on the interval from 0 to 2 pi. And then after that, we'll go ahead and start deciding how we want to write my answers. Now, solving an equation, you've been doing that for a very long time. You isolate the variable. You've got algebraic techniques to help you out. Even, factoring, things like that can be involved. So everything you know about solving an equation is really going to help you out with these. Your main goal is to isolate your trig function. Now, if you have multiple trig functions, then, you might have to get a little fancy with it, but I'm going to show you some of those. But let's just get right to it. Solve this one. Sine of theta equals 1/2. Okay, so we're going to be looking at these algebraically, but I also wanted to go ahead and take the first one and do it graphically, because really, if you're thinking about it graphically, you got 2 different graphs here. The graph of sine, and then the horizontal line 1/2. So really, any solution is where these 2 graphs would what? Where they would touch, yeah, where they intersect. Okay, so let's take a look at sine of theta. So it's been a while since we've seen sine. Does anybody remember the 5 critical points? What does he start with? Oh, not 1. 0. So he goes 0. Then we have our maximum. 0. Minimum. And then we have another 0, right? Remember, because he curved up and then down and back up. And then I can go ahead and fill in the rest of that pattern here. There we go. So this is sine of x, or sine of theta. Now, I'm going to go ahead and graph the line y equals 1/2, the other side of that equation. And I've already got a line ready right here. So let's say 1/2 is right about there. Okay, so this is y equals 1/2, and then we have sine of theta. So it's just like Christian said, everywhere these two graphs touch, that's a solution to this equation. So I have a solution here, and here, here, and here, and here. So can you see, if I were to continue rotating, whether clockwise or counterclockwise, then I'm going to have an infinite number of solutions? Okay, and we know those are going to be coterminal. Remember where you have a different measure, but it stops in the same location? So sometimes we're going to write our answers in that general form, and sometimes we're going to go ahead and just find solutions on a specific interval. Like if I were to go ahead and say, okay, I just want you to look on the interval from 0 to 2 pi, well, how many solutions should we be ending up with? Yeah, just 2, because I only see 2 intersections right there in that interval. Okay, well, let's go ahead and solve this algebraically. All right. And remember, we're always doing everything with triangles. Triangles, triangles, triangles. We like triangles. Okay, we did inverses with triangles. We did the unit circle with triangles. Same thing here for equations. Sine of theta equals 1/2. Well, because that 1/2 is positive, we have to ask ourselves, what quadrants will sine be positive? Okay, 1 and 2. Because remember, sine just represents the y value, right? So you could also ask yourself, where is the y positive? So I'm going to draw a triangle using the x-axis in quadrant 1. And I'm also going to go ahead and draw one in the second quadrant. So typically, you're going to be drawing, multiple triangles. Is it possible that you could have a triangle in all 4 quadrants? Yes, absolutely. In fact, we're going to have one of those before you guys leave today. Okay. Now, the thing about these triangles, they're going to be the same triangle over and over again. This triangle that I drew in the first quadrant is going to be exactly the same as the other one. He's just oriented in a different position. He might be reflected, rotated, whatever. Okay. What is sine's ratio? It's a y over r, right? Okay. So for each of these, we always go from the reference angle. So the opposite would be 1 with a radius of 2. Opposite of 1 with a radius of 2. Okay. What's the missing side? Okay, root 3. Okay. We can find that using Pythagorean theorem. And the only thing over here, because we're in the second quadrant, that x would be negative. Okay. Does anybody want me to run through the Pythagorean theorem? Show how we got that. Okay. Let's say we don't know what this x is right here. So you always use the legs as your a and b. So that would be x squared plus 1 squared is equal to 2 squared. Well, 1 squared is just 1. 2 squared is 4. Okay. And then x squared is equal to 3 because we subtract the 1. And where's the root come from? There you go. Because if we want x and not x squared, we have to take the square root. Okay. So there's my missing side. Okay, good. Good, good. Now, in the beginning, every one of these triangles, if it's not a quadrantal, is going to be either a 45-45 or a 30-60. Okay. What is this one? This one is a 30-60. Okay. Does anybody want me to go over the relationships that you should see between the sides? Okay. How do we know for sure it's not a 45-45? The two legs have to be the same. Now, it doesn't matter about sine. It just they have to have the same value. And here's what you're looking for. When you're solving these, you always, always, always start on the positive x-axis. Remember, we called that what position? Standard position. So I want to rotate to get that angle, and I want to rotate to get that angle. However many triangles I have in my grid. Okay. So this one's a 30-60. Is this reference angle, is that the 30 or that the 60? So if this one is 30, that's one of the solutions to my problem. Okay. Now, that means the other triangle, this reference angle is going to be 30 as well, but how far do I have to rotate to get that reference angle? 150. Okay. So those are going to be my two solutions. Now, depending on what the instructions say is going to depend on how you write your answer. Let's say I wanted you to find all solutions. So graphically, that means we are not going to stop rotating. I want every possible one. Well, there's no way you can write them all, which is why yesterday I showed you that general form, right? So first, let's go ahead and write these in radian form, because we always want to give our answer in radians. What is pi over, 30 degrees is pi over what? I almost caught myself. Pi over 6. Okay, so I'm going to say x equals pi over 6. Or in this case, the equation says theta, so I should probably use that. Okay. And then theta equals, what's 150? Pi over 6. Now for each of these, if I want every solution possible, meaning I want to be able to find all the coterminal angles for as long as I wanted, what am I going to add to these? Okay, the period. So what's the period of sine? So 2 pi n. And we're always going to say for all these general cases that n belongs to the integers. Your positive counting numbers, their opposites, and 0. Okay. So if I ask you to find all solutions, this is what you would go ahead and give me. Now, why did I add 2 pi n? We said sine's period was 2 pi, right? Is that going to be the same for every single function? What are the two I'm thinking of? Tangent and cotangent. If you're solving a trig equation and you isolate tangent or cotangent, you'll be adding pi n, because their periods are pi, not 2 pi. Okay, so that would actually give you the wrong answer. Does that make sense? Okay. Now, let's say for this problem, I didn't ask you to give me all the solutions. I said, I only want the solutions on the interval 0 and 2 pi. Now, some people today are saying they're liking the general form. Some people don't need to. Basically, whatever you think you need is what I would encourage you to use. If I'm only asking you for 0 to 2 pi, you don't have to write out the general forms. But if you like using those to find the answers, then I encourage you to do it. Okay? How did we do that yesterday? Yeah, so we just start plugging in numbers for n starting with 0. Okay? So n equals 0. These are going to be real easy. What's pi over 6 plus 2 pi times 0? Pi over 6. 5 pi over 6 plus 2 pi times 0. 5 pi over 6. Okay, so that takes care of 0, and now let's go to 1. And remember, you keep substituting until you get an answer that is not on the interval I'm asking you. So let's go ahead and try 1. So I need pi over 6 plus 2 pi. Okay. I mean, would that be larger than 2 pi? Definitely. In fact, can anybody tell me what it's going to be? It would be 13 pi over 6. Okay. So that one does not belong to the interval I want. So there's only 2 solutions in the one interval. And doesn't that kind of make sense? Because remember, when we looked at it graphically, what did we see? Yeah, there were only 2 solutions. In fact, this one right here should be pi over 6. What should this one be? 5 pi over 6. And then when you get to the next rotation, see, that's why we're adding 2 pi. That will give me every single coterminal angle, so therefore every solution to the problem. Now, there is something we did yesterday that we didn't do here. When we set these up, when we added the 2 pi in, we divided all of those by 2. Why didn't I do that here? There you go. You only have to do what the equation is telling you. See, we had sine of 1 theta. On the problems yesterday, we either had like 2 theta or 2x. Okay, so it really is specific to the equation. Ready, Xavier? Right. Okay. How we doing? Okay. Let's try another one. Okay. Now this one, 2 cosine of x minus 1 equals 0. We're going to do the same thing. Let's go ahead and write out the answers by finding all solutions. So we're going to put them in general form. And then I also want to find the answer specific to the interval 0 to 2 pi. And then after that, we're going to go ahead and start deciding what kind of answers we want to write. Okay. So I want this to read cosine of x equals. I want to get everything to the other side. So what would you suggest I do first? Add 1. Okay. So I'm going to add 1. Whatever I do to one side, I've got to do to the other. Opposites cancel. 2 cosine of x equals 1. And then now division is the opposite of multiplication. So those are going to cancel. So now this problem is just like the first one. Okay. Again, a lot of the techniques you've used in the past to solve equations, you're doing the exact same thing here. It's just now you've got trig expressions. Okay. So cosine of x equals 1/2. Now this one is pretty much already set up for us. So let's kind of see why we have these answers here that we do. Why do we have triangles in 1 and 4? How do we know to put the triangles there? That's where cosine is going to be positive. Okay, yes. So what if this had said cosine of x equals -1/2? Then it would be in 2 and 3. So you always base your decision on where to put the triangles based on the sign. Okay. Well, what's cosine's ratio? It's always x over r. So these two sides right here that are pushed right next to each other, those each have a length of 1, and then we have a radius of 2. Okay. What would be the missing height? Okay, so it'd be root 3. That would be negative square root 3. Okay. So it is a 30, 60, 90 triangle, right? Okay. Now, this reference angle right here, my first solution, that would have to be 60, like it is labeled, because that's across from the square root of 3, right? Now, here's where you want to be careful, because I've seen people do this in the past. If this is 60, that means this is 60 as well, right? So this angle is 30. So you want to be careful because you always rotate around. So it's not the 270 plus 60, it's the 270 plus, oops. It's the 270 plus 30. See, that's how I got the 300. Is everybody okay with that? Okay. So what is pi over 6? So 60 degrees is pi over 3. Okay. What's 300? Answer my own question. 5 pi over 3? Okay. Do you guys agree? Okay. There we go. That's all there is. Really, I think the only trouble people could have solving the equations is just manipulating the equation to get to a point where you can draw the triangles. I think once we get to that point, we should be good. Okay. In fact, let's say if I wanted all solutions, then I would say we have x here. So x equals pi over 3 plus 2 pi n. X equals 5 pi over 3 plus 2 pi n. Again, cosine has a period of 2 pi. That's why I'm adding it. Okay. Or if I wanted on the interval from 0 to 2 pi. See, now I'm very specific about one rotation. Okay. Well, if n equals 0, what are the first two? Pi over 3 and 5 pi over 3, right? Does that make sense? Okay. Now, we could check to see if we need to go any further, but I'm going to be willing to bet that we don't need to. If I were to take pi over 3, for example, and add 2 pi, would that be larger than 2 pi? Yes. So those are the only two solutions on that interval. Hey. That is more going from the unit circle. In fact, that's another way that you can look at this, and people have asked me the same question today. Like, for example, look at this one. What did we get to? We solved this. We said cosine of x equals 1/2. Okay. So all of these equations that I'm going to give you in the beginning are coming straight from the unit circle. So it has to deal with a quadrantal or one of the 12 points on there that make the special right triangles, right? So if you have a unit circle in front of you, you could really ask yourself this question. Okay, at what locations is there an x value that's a positive 1/2? So if I were to look at a unit circle, okay, let's see, I have a positive 1/2 right here, and you'll notice, where is it? Pi over 360 degrees. Okay. There's only one other location where that happens. There's a positive 1/2 for the x right there, and it does occur at 5 pi over 3. Okay. So it is true, if you have the unit circle in front of you, well, all you have to do is just pretty much look at it and you'll be able to get your answers, right? Will I be providing a unit circle? No. Now, you can go ahead and take the time to reproduce the unit circle. I mean, we did practice that. It's been a while, but we did. If you feel that time is worth it, I think that takes up too much time, and then you still got to solve the problems, right? Okay. So that's why I'm not, just looking at the unit circle. I'm focusing on the triangles. I'm focusing on what we know about the unit circle instead of just using it. Does that make sense? Okay. And maybe that's a good way to go ahead and check yourself. What answers did we get for the first one? What would I be looking for on the unit circle here? What kind of 1/2s? Is it the x values again? Specifically, what y values in the coordinates are a positive 1/2? So if I were to look, there's a positive 1/2 pi over 6, positive 1/2, 5 pi over 6. Okay. All right. Oh, that's going a little too far. I think we got this one. Okay. Let's try these problems. Okay, now for this one, number 3, let's go ahead and find all solutions. So that means I want to write my answers in a general form. The only time you won't write your answers in a general form is if you're given a specific interval. Is everybody okay with that? Okay. So this one, I'm going to go ahead and get you to the point where we have sign equals, and then I'm going to turn it over to you and let you take it the rest of the way. So here we do have 2 trig functions, but they are the same, so I have to somehow combine those. What would you like me to do? Should I move the left sign to the right or the right sign to the left? So you want me to move the right to the left? Okay. Well, I've got a negative sign here, so the only way to get it away is to do the opposite. I'm going to add sign to both sides. So what's a sine plus sine? 2 sine plus the square root of 2 is equal to 0, because those opposites cancel. Okay, so let's subtract the root 2. Okay, so those are going to cancel. 2 sine of x is equal to negative square root of 2. And then divide by 2, because we just want sine of x. And you'll notice when you start isolating these, should you recognize some of these ratios that you're seeing? Yeah, because everything right now is based on the unit circle. Now, once everybody's comfortable with these, then we'll start looking at equations where they're not on the unit circle. Okay. You may need a calculator, but I'm also going to show you how to do it by hand.
Oh, okay.
Yeah. So you don't necessarily need the calculator to do it. If you want the approximate answer, yes.
Oh,
Okay.
okay.
All right, so I'm going to go ahead and turn this over to you, let you guys finish it up. Okay, right, Xavier? So you got the answer already? Okay. So while you guys are doing that, I will pass back your papers. Because remember, what's on that quiz tomorrow? Double angle identities, and I want to pass this back because this is really good practice. In fact, like I said, numbers 1 and 2 are very similar to what you should see on the quiz tomorrow. Okay, so there you go. And so, Stephanie, Varun, Red. Oh, Red's right here. Kyle left. Football buzz. Oh, by the sign. So because sign is negative, in what 2 quadrants would sign be negative? There you go. That's right. easy. All right, so let me go ahead and catch up to you. Okay, if you are done, great. If not, that's okay. All right, so where should I go? What quadrants am I going to place these in? Okay, why 3 and 4? Okay, because it's negative. So I'm going to draw a triangle in the third quadrant, triangle in the fourth quadrant. Okay. We know sine's ratio y over r. So from each of these reference angles right here, we're going to go, the opposite is the negative square root of 2, and each of them is going to have a radius of 2. Okay. And that is correct. Pythagorean theorem is going to show me that each of these missing sides is the square root of 2. Okay, don't forget the negative on that one in the third quadrant. Okay. And this is absolutely a 45, 45, 90. Okay, we can tell that immediately because the two legs are identical. Now, wait a minute. Over here, one's positive, one's negative. Does that matter? That does not matter. It's only the expression. The negative just tells me direction. Okay. So remember, always start here. So I want this one, and I want this one. Okay. So let's start with the degrees. What would 180 plus the 45 be? 225. Okay. And then 270 plus an additional 45. Okay. Would you guys agree? Okay. And now just go ahead and convert them. What is 225 degrees as a radian? Okay. So 5 pi over 4, and x equals 7 pi over 4. Now, if I want the general, all the solutions, what am I forgetting? Plus 2 pi n. Okay. There you go. How many people got that right? Okay, good. Good, good. A lot of hands going up. If you're not raising your hand, is there anything I can do to help? Are we getting a value? You're not seeing where it's coming from. Great questions. Okay, all right. Okay, let's take a look at the next one then. All right, let me go ahead and move this one over just a little bit. Okay. 18 cosine of x minus 7 equals 14 cosine of x minus 5. Okay, so you'll notice as we go through, they're going to start to get a little larger. We're going to have to start using different techniques, and that's okay. So somehow I want to rewrite this so I have cosine equals. What should I move first? And does it really matter what term I move first? No. Okay, you want me to move what forward?
I don't know. I just did it all at once.
Did it all at once? Like, how do you mean? Oh, you kind of just did it in your head? Or,
Yeah.
oh, okay, so I see what you mean. Like, if you moved this cosine over, you move this constant at the same time? Okay. Now, does anybody want me to continue showing these steps, or can I go ahead and start doing that without showing them? Does anybody want me to show those steps? Okay. You do? Okay, so I'll go ahead and do that. So let's say I subtract this 14 cosine of x over. And I'm going to go ahead and subtract it because it's positive right there. Okay, so those are going to cancel. How many cosines will I have? 4. 18 minus 14. So 4 cosine of x minus 7 is equal to negative 5. Now I'd want to move the what? Okay, so I'm going to add 7 to both sides. See, what I'm doing is I'm getting that cosine, that trig function, all by its lonesome. Those are going to cancel. So 4 cosine of x equals 2. And then now my last step is to what? Divide through by 4. So I've got cosine of x equals 1/2. And that's what I'm really thinking might be the challenge, just getting to that point. Because I'm hopeful from here, drawing the triangles, recognizing those, we should be able to do that. But does anybody recognize anything about this one? Yeah, this is the one we just saw. See, it's just another equation that got me to the same response. So what did we say for that one? It was pi over 3 and 5 pi over 3. Okay. Oh, I put those out of order, but that's okay. All right. Questions. All right, we have one more to look at. This is as far as first period made it today. Okay. So I'm actually really happy. I mean, we're making it further into the notes on the first day than I thought we would. So I'm really happy about that. Yay. Okay. All right, but this one we're going to go ahead and do a little different. I don't want all the solutions. I just want every solution on the interval from 0 to 2 pi. So I don't want the general form, okay? I want the exact solutions on that interval. Now, if it helps you to write out the general and then start plugging in values for n, please feel free to do so. If you don't think you need the general form, don't worry about it, okay? Now, I'm going to go ahead and get you to the point where you would draw the triangles, and I'm going to let you take it from there. Or do you want to try that one on your own as well? Let's do that. Let me give you 1 minute. Solve that equation for sine. So we want sine of x equals. We want to get rid of everything else. Let's see if we can all get to the same point. And if you think you have it, you feel confident, you can go ahead and keep going on with the triangles. Okay, if you want to check with your villain partner, okay, see if they're getting the same thing. Okay. All right, so that's been about a minute right there, probably a little longer. So walk me through this. I want it to be sine of x equals. What would I do first? Okay, so add the 1. Get rid of any extra terms first. All right, so those are going to cancel. 4 sine squared of x is equal to 1. Now what? Okay, divide through by the 4. When those cancel, sine squared of x is equal to 1/4. Now this one's different. I want sine, not sine squared. So what would I do? There you go. If I had x squared equals and I wanted x, you'd take the square root. So I'm going to do the same thing to both sides. So that would give me sine of x equals what? Okay, 1/2. There's something I'm forgetting. Plus or minus. When we're solving an equation and we have to take an even root, we want to put the plus minus in front of it. Now, why does this also make that a different kind of problem? What does that mean for your triangles? Basically, so where is sign positive or negative, you're going to have a triangle in all four quadrants. But the good news is it the same triangle or different triangles? It's still the same triangle, just in a different position. Okay. Bless you. Okay. All right, so I'll give you a little more time to go ahead and figure out what type of triangles we're dealing with, figure out the angle measures, and then we'll come back together. Now remember, I don't want the general form, I want the exact answers. So I'm looking for this one, this one, this one, and this one. We always start rotating from standard position. That looks kind of cool, right? See, it's like art. If I were walking through a museum and I were to see that, I would stop and go, oh. I don't know art, but I know what I like. Isn't that the saying? I'm going to let you do your math. And this is going to be our last problem for today. If you kind of want to start just looking ahead, you'll notice number 6 is our first tangent equation. Number 7 is our first equation to have different trig functions. So we're going to have to do something that you're very familiar with. You may not remember the name. And then even ones where we're going to have to start using identities. Okay, so we'll kind of see how that plays out. Excuse me. Okay, let's go back to the beginning. Is there anybody who's not sure how we got down to sine of x equals plus or minus 1/2? Or why we need a triangle in every quadrant this time? Okay. So every radius should be 2. Okay. Every opposite side from a reference angle is either going to be 1 or it's going to be -1. Again, depending on the quadrant. What's the missing side? Again, root 3. So this one is a square root of 3. This one would be a negative square root of 3. Okay. So very important. What would that angle be there across from 1? It would have to be 30. It is a 30, 60, 90. But every one of those 4 reference angles would be 30. So my first solution would be 30. Now how far do I have to rotate to get that reference angle again? If I wanted to have 30 left over before I got to the x-axis. So that would be 150. Now I'm going to add another 30 to 180 because this one right here is 30 degrees as well. Okay, that would be 210. And now here's where you want to be careful. Okay, that's 30, so that means this would be 60. So 3/4 we know is 270 plus 60. So that'd be 300 and what more? 330. Here we go. And maybe this will help you out in the beginning. Okay, if you want to go around and label them in degrees, and now what's 30 degrees as a radian? So pi over 6 is my first answer. 150, 5 pi over 6, 210, 7 pi over 6, and finally 330. Okay, 11 pi over 6. So those are my 4 answers. Now, one thing to keep in mind, had I asked for all the solutions for this equation, then I would have had 4 general expressions. Every one of those I would need to add 2 pi in. Okay. Anybody having trouble with equations? How many people got that one right? That's good. That is really good. Okay, fantastic. These kind of problems right here, this is what your test next week is going to be over, the majority of it. Okay, now it's not on the quiz tomorrow. The quiz is just a double angle. Okay, all right, good. Looks like we got less than 5 minutes, so let's go ahead and shut